Hi everyone. In this video I'm going to go over some quadratic applications. And so the big idea of quadratic word problems is you have many different forms of quadratic equation, and each different form gives you different properties very easily. And so often when we're solving these problems, we first need to figure out what part of the parabola it is that we care about. So it could be the vertex would be the maximum or minimum value. It could be the y-intercept, which is the initial value, or it could be the zeros, the x-intercepts. And sometimes it could also be the direction of opening. Is it increasing or decreasing? Where is it increasing? Where is it decreasing? Right? So if it's downward facing, say, like if it's downward facing, then it's increasing up until the vertex, and then it's decreasing after the vertex, right? So all of these are different things we can get from different parts of our parabola. And so what I'm going to go over today is a couple of word problems to show you how you can take a quadratic in a given form and turn that into a form that's more useful for finding various features. So let's jump right into an example. A pumpkin is thrown off a balcony. The height, h in meters, of the pumpkin above the ground, t seconds after being thrown, can be modeled by the equation h of t is negative 5t squared plus 8t plus 3. Okay, so h is the height of the pumpkin at any given t time. Determine each of the following. How high was the pumpkin the moment it was released? Okay, so the moment it was released, moment of release, what does that mean? Well, if it's being thrown, the moment it's being released is going to be the initial time. So when time is 0, that's the point that it was thrown. And so how high was the pumpkin when it was released? Well, we are going to do the height at 0 seconds. So we just substitute that value into our equation. And the nice thing about 0 is our negative 5t squared is just going to disappear, right? Because 0 times anything is nothing. And our 8 times 0 is going to disappear because 0 times anything is nothing. And so we're left with 3. So when released, the pumpkin is 3 meters above the ground. Cool. So let's move on to our next question. Question 2. What is the highest point the pumpkin reaches? So if we sort of think of, just a rough, super rough sketch of what's going on here, we've so far figured out that the pumpkin is released at 3 meters height, and presumably it's being thrown up into the air and it's going to land at some point. And what it's asking for is the highest point the pumpkin reaches. And the highest point the pumpkin reaches is going to be the vertex. So what is the highest point the pumpkin reaches, and how long did it take to reach that height? So the time is going to be the x component of our vertex, and then the height is going to be the y component of our vertex. So we need to get this into vertex form. So in my last video, I showed you a few ways to get from vertex form. I'm going to do the standard completing the square method in this video. But in my last video in this series, I showed you some other options you could do as well. And they're all equally great in my opinion. So completing the square, what we're going to do is we are going to first common factor out that negative 5. So that leaves us with t squared plus positive reduced by a negative is going to make this negative 8/5 t. And then that negative 8/5 t, we are going to half it, square it, add it, subtract it. So half of 8/5 is actually going to be 4/5, right? Because half of 8 is 4. And we need to square it, add it, and subtract it. Half it, square it, add it, subtract it. That's how you complete the square. And then our plus 3 is just chilling outside. Okay, so negative 5. This part here, I can complete the square with. And so I'm going to get t, since this is negative, is going to be minus 4/5. squared. Now, this negative 4 over 5 squared, I actually need to distribute my negative 5 across. So 4 squared is 16. The 5 I don't need to square because I'm multiplying by 5 in front. So when I multiply the 5, it's going to reduce one of my two 5s. So this is going to be 16 fifths. 16 over 5, and it's a negative times a negative, which makes this plus 16 fifths. And my 3 on the end, I guess I'll turn into fifths at this point. So that is 15 fifths. Now, since this is a word problem, I'm actually going to take all these fractions, I'm going to turn them into decimals. Usually when you're dealing with word problems, you actually want decimal values because then you can interpret them more easily. So I'm going to do t minus 0.8 squared plus 16 plus 15 is 31. 31 divided by 5 is 6.2. So what is the highest point it reaches? Well, the highest point it reaches is 6.2. So it's a max height of 6.2 meters after 0.8 seconds. Right, it's positive 0.8 seconds because you need positive 0.8 minus 0.8 to get 0 for your vertex. Last question is probably the hardest one for this one. How long until the pumpkin smashes onto the ground? So we're looking then for this point here. We're looking for the 0. Now we actually need to be a little bit careful because our equation, there's nothing preventing us from putting a negative value into our equation. It just doesn't make sense for this question. So we're actually going to get two x-intercepts here. We're going to get an x-intercept here to the left that doesn't actually make sense, and we're going to get an x-intercept here that is the one that we care about. So let's take our equation, 3. So h of t equals negative 5t squared plus 8t plus 3. And in this case, I actually want the zeros of the function. So I want 0 equals negative 5t squared plus 8t plus 3. Now I could try to factor this. 5 times 3 is 15. Are there two things that multiply to 15 and add to a negative 15 that have a difference of 8? No, there's no two things that have multiply to negative 15 and have a difference of 8. Right? 5 minus 3 would be 2, right? And 15 minus 1 would be 14. Okay, so this doesn't factor. So we're going to have to use our beautiful quadratic formula, which I guess I'll sing for you guys, because why not? X equals negative b plus or minus square root b squared minus 4ac all over 2a. Ha, you thought I was done with Pop the Weasel. Nope. So here we go. There's our quadratic formula with our values substituted. So now all we need to do is simplify. So x equals negative 8 plus or minus square root, let's see, 4 times 5 is 20, 20 times 3 is 60, and the two negatives make it positive. So this is 64 plus 60 would make it 124 over negative 10. Now this is kind of a cool thing. We've got plus or minus for this square root thing. So it's going to be both positive and negative. And here we've got a negative over a negative. So we can actually take both of those negatives and turn them into pluses if we like, because we already have plus and minus here. So it doesn't matter the order if you minus plus or plus minus. It's the exact same thing. So I guess I'll just drop my negatives to make this a little bit easier for myself. So now I'm going to get two solutions, or two zeros. I'm going to get x equals 8 plus root 124. Now root 124, I don't really want to put root 124. We want a decimal number anyway because this is a word problem. So 121 would be 11 squared. So root 124 should be about 11.1. And if you check it in a calculator, it actually is 11.1 rounded correctly, which is really convenient. So that root is going to be 8 plus 11 is 19.1 over 10. Hopefully you don't need a calculator to divide by 10 to get 1.91 seconds. And our next is going to be 8 minus 11.1 over 10, which is negative 3.1 over 10, which is negative 0.31 seconds. And so, right, if we think back to our sketch, this one here is our negative 0.31 seconds, and this one here is our 1.91 seconds that we actually want. So this is our root, and this one here, this negative value, this, oops, I lost it. Not sure how that happened, but anyway, this negative 0.31 seconds is called an extraneous root, which is just fancy math words for it doesn't actually make sense. Negative time doesn't make sense in this question. So let's, since this is a word problem, let's actually write out our answer. So the pumpkin gets smashed after 1.91 seconds. All right, so hopefully you sort of see how we can get different properties of our quadratic from different forms. And so word problems are generally about moving a quadratic into the form that makes sense for finding that particular property you care about. Let's try another example. Okay, a theater company can sell 2,000 tickets if they charge $50 per ticket. After analyzing their past shows, they have determined how price changes will affect their sales. For every $5 they increase their ticket price, they will sell 100 fewer tickets. What price should they set to maximize their total revenue? All right, so let's figure this out. Now, what makes this kind of confusing is we increase by $5, right? So for every $5 they increase the price, or the ticket price, they will sell 100 fewer tickets. And so the really confusing thing for this question is we actually want our variable to be the number of price increases. So let's let x equal our number of price increases. And the reason we want that is that our ticket price is going in multiples of 5, and our ticket sales are going in multiples of 100 based on our number of price increases. So the thing that they're actually doing is increasing by $5 multiple times. So the x that we want is going to be the number of times they change the price. Now, I've also given you guys, if you haven't taken economics or business or whatever, revenue is the fancy business word for the total money you take in. And it's the price of the things times the number of the things, right? So it makes sense. If you sell 10 chocolate bars for $2 each, it's $2 times 10 chocolate bars, okay? So let's figure out what our price is. Our price is going to be our $50 plus $5 per x, right? So every time that they increase the price, if they increase the price once, then that's going to be 50 plus 5. If they increase the price twice, that's going to be 50 plus 10, and so on. And then the number that they sell is going to be 2,000 tickets less 100 tickets for every time they increase their price. Right? So if they increase the price once, they will sell 100 fewer tickets. So if x is 1, it's 2,000 minus 100. If they have 2 price increases, it's 2,000 minus 200, and so on. And this gives us a revenue function. So our revenue is 50 plus 5x times our number, 2,000 minus 100x. And we want to figure out the maximum revenue. So the maximum revenue, like presumably we're going to have some sort of curve like this. We're trying to find the maximum of that curve, which is the vertex. So we need to get vertex from this form that we have here for revenue. And that form is essentially factored form. We can get our x-intercepts from this really nicely. So this one here, if we set 50 plus 5x equal to 0, then we get a 0 of x equals, so negative 50 when we bring it over, divide by 5 is negative 10. And we can get another solution from here. If we bring the negative 100x over to the other side, we get positive 100x, and then divide by the 100, we get x equals 20. So those are our two zeros. So this is at 20, and this is at negative 10. So where's the vertex going to be? What's halfway between negative 10 and 20? It's 5. And if you can't do that in your head, the long way to do it would be negative 10 plus 20 divided by 2 is 10 divided by 2 is 5. So all that we need to do is substitute x equals 5, right? X equals. So substitute x equals 5 into our revenue equation. So revenue is 50 plus 5 times 5 times our price, or sorry, not our number of tickets, is 2,000 minus 100 times 5. So our revenue is 75 times 1,500. And that is going to be the price and the number that maximizes our revenue. And so I think we've already answered the question, but since we're here, might as well just figure out what our total revenue is. If you multiply those two together, you get $112,500. So what was the question asking? What price should they set? Oh, we've already figured that out. So the price that they should set is $75. The $50 plus 5 price increases. And x right here is, of course, the number of price increases. So let's write this all up. If they increase the price 5 times, the price is $75. Sales, the number of tickets will be 1,500 tickets. And the revenue will be $112,500. There we have it. A ticket problem. Anyway, I hope from this video you see how you can use the different forms of quadratic equations to get different properties, like the maximum value, like the zeros, like the y-intercept. And depending on the context of the problem, you might care about different things. Good luck solving your problems.